Okay. This is the final design of several. Or, well, it's the final design that I made the workarounds for the design the team gave me. What I've done is offset the copper cart 1 inch, so there's more room for the bauxite holder. The bauxite holder will be a round corner square on the back part of it, made out of pressed sewer pipe. It'll be 4 inches in diameter, and it will fit from the middle of the robot all the way back. And it can hold, and this portion of it can hold about 3, maybe 4 bauxite. This front portion is going to be wider, as wide as we can get it, and it will be able to hold 6 bauxite at most right in here. This will be a prong arm, this line here. It will have a servo that moves it out and presses it against the wall underneath the overhang for the bauxite to collect it and direct it into there. This can catch about 10 of the box out of 16 of the bauxite, which limits us significantly. The copper cart can still be dealt with. The caster wheel will have to be offset just a little bit to make sure it doesn't get in the way of this. The bauxite holder itself will likely be working as our skid if we find that we can't balance on 3. This portion here will be where our arm is. We will want it higher than the wheels. We have our robot 4 inches off of the ground, approximately. Or at least that's how it's supposed to be. I might have done my scale wrong. Anyway, the bauxite holder will need to become disattached because we found it was ineffective to try to drive backwards and get the aluminum out the bauxite. Okay, it will be on a shelf, essentially. Basically, it will have 3 or so loops molded into the top of it, molded and cut into the top of it. I can show you more what I mean there in person. And they will be hanging on prongs that stick out of the chassis themselves, with 1 servo in the middle holding it onto the prongs, keeping it from slipping off. It's not actually supported by the strength of the servos, nor is the servo in danger of being damaged if somehow the bauxite holder is impacted. Okay, when the servo would come loose, the bauxite holder would slide off of the angled prongs, and this is one-time use. You can't get it back on. And the bot would have to back up 2 feet in order to and then turn in order to disengage. I think that's about it for this. We would have 10-inch diameter wheels set on a box, essentially, that made them only have 4 inches below and 6 inches above the bottom part of the chassis. And that's just about it. There's not much I could figure out to do with this. It would be able to get to the copper, completely, of course. Almost all of the magnetite, if we could get it to, if we can place it correctly and get it to actually pour into it. And it would be able to get a little bit of either the spodumene or the coal, but not both. And not much of either at that. Because since it is only eight inches, my scale is wrong, 8 inches wide and 12 inches long, that is about 80 square inch, 104 square inches. No, let me check my math real quick. Anyway, $96 square inches. Anyway, that's about it for this one. It does not have much ability to catch falling materials, nor does it have much overall capacity in the first place, and it would probably be a tad sluggish because of having to haul this ridiculously heavy thing and having to slide on this. Now, my design, which I only started working on after I completely finished the other one, is this. Okay, the basic idea with this is the body of the robot is our cargo bin. Okay. These are the different steps that I went through essentially. Fold out walls that could fold back in when they slide on the tunnel walls. A scoop, and that one's improperly placed, I fixed it here. A shovel-like scoop that would start upright like this, so that the bot itself can still fit within the 24 inches, or 2 feet. Once we start, this would fold down, or in a driving position here, where it's not actually touching the ground, and would fold all the way down when we need to pick up stuff. The arm mount would go there. This would be an overhang. Basically, you'd still have capacity underneath. Okay. Yeah, this is a little bit complicated amount of stuff that I have to explain to you in this one, but it's a better robot overall. Okay. I didn't properly scale it, that's why this is here. It would be curved to be more efficient in catching stuff and dumping it into here, and we can do that. We can do that during the build process, figuring that out. Hinges, it would be on hinges to fold back and forth. And that sidewall, since I took out that one, this sidewall will be on hinges to slide back upright on a tunnel wall. That, when it hits something, would push the sidewall back upright so that it's no longer sticking out. But that allows to catch more things on the left side, specifically the coal and somewhat the spodumene. Okay, the wheels are still 10-inch, still a 10-inch diameter, but they are set below the chassis at their center point, so that we have surely I didn't do that right. Something tells me I scaled something wrong. No. There we go. Okay, 5.5 inches, sorry. The dump mechanism would be the back wall opening with about one servo to do that, and you would get the stuff out by a slosh effect. You'd open the wall, drive backwards to the robot starting ox, and then drive forwards once you reach that spot to essentially slosh the stuff back out. The arm mount would go up on this. This would not actually be a solid block, more like a tower kind of thing, and so that it could reach over the wheels. The cortex would go underneath that if it fits. I don't actually know the exact specifications of that. This groove would be for holding the core sample, and this spot would be where the, if it could fit, though I figured out it probably couldn't actually, but that would be for where the magnetite could be laid down. But actually I think what it would be is the magnetite would be hitting somewhere there. But that's unimportant. Okay, the battery mount would go up here, and we'd have easy access to it, following the rules. When it's in its upright folded position, this here, and it's not actually going to be solid, it would be the struts. This rod would keep it from tipping too far back. Right here, it would be connected to a motor that would be set here. Yeah, that's actually what that's doing. Sorry, forgetting where I put some of my stuff. But the motor would be connected here. We'd have a belt system that would run it over to a rod kind of thing there. And that would actually tip this. And if we found we needed more power, we could possibly stick a servo on there. Hopefully we wouldn't, because the motors tend to be good enough. We'd certainly make this light, though. Is there anything else I need to say? Oh, yes. The chalcopyrite cart, the copper cart, the chalcopyrite would be obtained by having this actually be lower. I haven't done that yet. This one wall be lower, and driving up to the copper cart, moving the arm behind the copper cart and swinging it to knock the copper cart over into this upside down, and then the arms knocking it back out, leaving the copper behind. Since it's so wide, it would be very good at catching the spodumene and the coal. Yeah, spodumene. And I think that's all that I need to actually say. Oh yeah, and we have a 1-inch ground clearance for the box itself. That should help. Oh, yes, the prong arm. Okay, the prong arm would be mounted on here, on the scoop itself, unless we found that was too heavy, in which case it would be mounted here, and we'd probably have to take this fold-out wall off. Because I haven't actually been able to test some of this stuff, not having a field. Anyway, the prong arm would be on the servo, and that would fold out to actually go underneath the overhang for the bauxite,